Hey students, this is lesson 10.3, areas of regular polygons. Our objective here is to find the area of a regular polygon. We're going to learn this formula for doing that, so pay attention to that. Go ahead and do this vocab section and you can check back with your answers. And you should know that this word in the vocab, very important word here, is pronounced apothem. So, and that is the perpendicular distance from a side to the center in a regular polygon. And we're going to need that. All right, so first of all, you have to be able to find angle measures to find areas. What we have here is a regular hexagon. The radii are these. This is a radius right here. And we want to know what is the measure of each numbered angle. If it's a regular polygon, then we know that we're going to create some congruent triangles. So all 6 of these triangles are congruent. And we know that there's 360 degrees in a circle. So to find the measure of angle 1, we're just going to take 360 divided by 6, which is 60. So the measure of angle 1 is 60. Now to find the other measures, if I draw this line in here perpendicular, it's actually a perpendicular bisector of that central angle. And so the measure of angle 3 is equal to 1/2 of the measure of angle 1. And the measure of angle 1 we just found out is 60, so that's equal to 30. So the measure of angle 3 is 30. Now the measure of angle 2 plus the measure of angle 3 plus that angle there, 90, is equal to 180 by the triangle angle sum theorem. And so the measure of angle 2 plus the measure of angle 3 is equal to 180 minus 90, which is 90. And we know that the measure of angle 3 is 60, or is 30. We just figured that out. So we're going to substitute 30 in there. Then we're going to subtract 30 from 90, and we get the measure of angle 2 is equal to 60. So we have all 3 of those angles. Angle 1 is equal to 60 degrees. Angle 2 is equal to 60 degrees. And angle 3 is equal to 30 degrees. All right, I'm going to pause here and let you do the next problem. You can check back with your answers. All right, postulate 10.1 says if 2 figures are congruent, then their areas are equal. And we're going to have a lot of that going on when we have regular polygons. So if the area of triangle AOB is 24 square inches, then the area of BOC is also 24, because those are congruent triangles in that hexagon. If the area of triangle BOC is 8 square centimeters, then the area of triangle AOC is 16, because there's 2 of those triangles in there and they're both congruent. And then the other thing is the area of finding the area of a regular polygon. We're going to use this formula. The area of a regular polygon is half the product of the apothem and the perimeter. So so all you need to do is take 1/2 times the apothem times the perimeter to get the area. So if the apothem is 10, that's that, and the perimeter is 80, we're going to multiply 1/2 times 10 times 80. If the apothem is 5 and the perimeter is 30 times the square root of 3, we're going to multiply 1/2 times 5 times 30 times the square root of 3. And if the apothem is 5 square root of 3, we're going to take 1/2 times 5 times the square root of 3 times the perimeter, which is 60. So we're going to use that. So, what is the area of the regular octagon below? we're going to use this formula, 1/2 AP. Just going to mark a couple things. 14.5 is the apothem. The perimeter we're going to get by taking the number of sides times the length of one side. In this case, the number of sides is 8 and the length of one side is 12. So that's 96. So our area is 1/2 times 14.5, that's the apothem, times 96. And that equals, we use our calculator, 696 square centimeters. All right, I'll let you try one of those using that formula. You can check back with your answers. All right, sometimes in certain shapes we're going to use some ideas, special triangle ideas to help us find the area. We are going to use the same formula, area equals 1/2 times the apothem times the perimeter. But in helping us find the perimeter, sometimes we need to use some other properties. So it says here each side is 5 units long, and we want to know the area of the gazebo. So I'm just going to put a center in here and then draw the triangle. And all these triangles would be the same, since it's a regular hexagon. Now, to use this formula, I need to know what A is. So I'm just going to mark that. And then I know that each of these angles are 60 degrees, because we have 360 divided by 6, which is 60. So that tells me that one of these angles right here is 30 degrees, since that's a perpendicular bisector. And since this is 90 degrees, I know this is 60 degrees. So I have a 30, 60, 90 triangle right there. So this short length from here to here, I'm going to label that. I know that's half of the side length there, which is 2.5. And from what we did earlier, we know that the long leg in a 30-60 triangle is equal to the square root of 3 times the short leg. So that means that, and the long leg just happens to be the apothem. So that line right there is 2.5 times the square root of 3. So now I have everything I need. I'm going to take 1/2 times 2.5 times the square root of 3 times perimeter. I'll put that over here. Perimeter is just the number of sides times the side length. So in this case, it's 6 times 5, which is 30. So times 30. And then we're going to round that to the nearest whole number. And that's going to be, we use our calculator, 65. Now be careful when you use your calculator. When you do the square root of 3 here, you have to close off that parentheses to get it to calculate it correctly. All right, so I'm going to let you try that. You can check back with your answers. All right, that's it. Here's a lesson check. What is the relationship between the side length and the apothem in each figure there in a square? So we want to look at what kind of triangles we form using the apothem and the side length. And with a square, we end up with an isosceles triangle that has 45-degree angles. So that's a 45, 45, 90 triangle. In a regular hexagon, we saw earlier, we end up with a 30 to 60, 90 triangle. And with an equilateral triangle, since an equilateral triangle has 3 60-degree angles, that makes this a 30-degree angle, and this a 90, so we have a 30, 60, 90 there also. Now using our, what we know about 30, 60, 90, and 45, 45, 90 triangles, for square, the legs will Well, the two legs actually equal each other, and they're half the side length. So the apothem is half the side length. In a regular hexagon, the longer leg is square root of 3 times the shorter leg, so the apothem is square root of 3 times 1/2 of the side length of that hexagon. We can simplify that to the square root of 3 over 2 times s. And the longer leg in an equilateral triangle is the square root of 3 times the shorter leg. And so that means the longer leg, which is 1/2 s, is equal to the square root of 3 times a. And that gives us s is equal to 2 times the square root of 3 times a. All right? And that's the lesson. I'll see you tomorrow.